dot structures help us to take the formula of a compound and translate it eventually into a three-dimensional shape. We need Lewis dot structures to help us determine what that three-dimensional shape is. In order to do this, you want to have a good understanding of how valence electrons are determined for particular elements and what a covalent bond is. There's a list of directions or steps, steps is a better way to put it, on how to draw a Lewis dot structure. And you can read through these here, and it might be a good idea to have these open in some way as we walk through some examples here. Basically, you want to add up all the valence electrons for the atoms in the molecule. And then there's an important step, which I don't actually have in here, but which you want to remember, is you want to forget where those electrons came from. Because sometimes people think, oh, the phosphorus brought 5 electrons into the molecule, so I need to make sure that those 5 electrons make it back on the phosphorus. That will actually cause you some problems later on, and it may be kind of confusing, and it makes Lewis dot structures a lot more difficult than they need to be. So sum up all those valence electrons, and then think of that as just a group of electrons that you're drawing from to put on your molecule. Then you're going to choose a central atom. It may be the thing that's written first in the formula, like for instance in CO2, carbon is written first in the formula, so it's probably the central atom. It needs to be something that can actually make the bonds. So when we think about this, I'm talking about the fact that, say for carbon, it has 4 valence electrons. If we were to draw those electrons as dots around carbon, we would draw it like this. Carbon is going to make bonds so that it has access to 8 electrons total. So we can think about carbon as having 4 empty spots where some other electrons can be added. Let's say, for example, we were going to have hydrogen come in. Hydrogen has 1 electron. So if that 1 electron went right here, then we would have carbon now having access to that electron plus its own electron, and that would form a covalent bond. And if carbon did that 4 different times, then it would have access to 8 electrons. So you can think about this issue as being, is the central atom able to make the bonds that are needed? Now, of the ways that we determine the central atom, this is probably the one that you use the least likely at this level, at the introductory level. The next one, that it's generally the least electronegative element, also is something to be aware of, but not as oftenly used. Pretty much if it's written first, or there's only one of it, we should say, or only one, that's often your central atom. And then the last one here with carbon is often the central atom. Hydrogen and helium are never central. Pretty much these two guys are main decision-making factors often. In step 3, you'll place 2 electrons for each bond, and just as I did up here, an electron equals a dot in a Lewis dot structure. And you'll put the other electrons around the outer atoms until each has a full octet. Remember, that means everybody has access to 8 electrons. The remaining electrons, if there are any, go on the central atom. All right, so let's talk about how to do this. Let's take, for instance, PCl3. We need to total our valence electrons. Phosphorus has 5 electrons, and each chlorine has 7 electrons, and there's 3 chlorines. So I have 5 plus 21, which gives me 26 electrons total. At that point, I'm interested in the fact that I have 26 electrons. I'm not interested in the fact that some of them came from phosphorus and some of them came from chlorine. My central atom, when I check out my formula up here, I see that I have phosphorus written first, and there's only one of it. Carbon's not an option, so phosphorus is going to be my central atom. In addition, phosphorus can make the bonds that I need it to. I'm going to think about phosphorus as having a box around it, just an imaginary box with 4 sides. And I'm going to arrange the chlorines around the sides of that box. It doesn't matter whether I put the chlorines around these 3 sides or I use the side at the top. It doesn't really matter, as long as I've got them on the different sides. Next, if we check our thing here, we're down here to number 3, we want to place 2 electrons for each bond. So I'm going to take these 26 electrons, and I'm going to start putting them on my molecule. I see that I have a bond here, so there's 2 electrons in that bond. And I have a bond here, so there's 2 electrons for that bond. And then I've got a bond here between this phosphorus and this chlorine, and that takes care of those electrons. That removed 6 electrons from my collection. Next, I'm going to put electrons on the outer atoms until they have access to 8. So right now, each chlorine has access to these 2 electrons, or these 2, or these 2. They each need access to 8, so they still need 6 more. So I'm going to add 6 more, again, imagining that box around the element, and adding dots to represent the different electrons I'm adding. That's 18 more electrons that I've just used up. I have 2 electrons left. At this point, chlorines all have access to 8 electrons. So they're perfectly happy. They don't need any more. Phosphorus, on the other hand, at this point in time, only has 6. It needs 8. I can plop the last 2 electrons right there on the top of phosphorus. At this point, I've used up all my electrons. Everybody has access to 8 electrons. I don't have to worry about hydrogen or helium because they're not present in my molecule, and I'm good to go. So, what if you don't have enough electrons? Here's HCN. Let's start by summing up our electrons. Hydrogen gives me 1, carbon gives me 4, and nitrogen gives me 5, for a grand total of 10 electrons. My central atom here, hydrogen's never a central atom because it only makes 1 bond, so it can't be hydrogen. Carbon and nitrogen are my other choices. If I've got carbon in the compound, carbon's my central atom. So I'm going to put carbon in the middle and put the nitrogen and the hydrogen on either side. Now, again, we're just imagining that box around carbon, and I could have put the hydrogens and the nitrogens on any of 2 sides of the box. I'm going to add electrons to my bonds first to make those, and that takes care of 4 of my electrons. I have 6 electrons left. At this point, hydrogen is thrilled. It has the 2 electrons that it needs, and it's done. Hydrogen's set. Nitrogen, on the other hand, my other outer atom, still needs some more electrons. So I'm going to add them, at which point I have used up all of my electrons, and nitrogen is perfectly happy. It's got access to 8 electrons. The problem is, you can probably see the problem, is that carbon only has access to 4 electrons right now. So the question becomes, what do we do to help carbon out? Well, it turns out that I can actually take 2 electrons from nitrogen and put them into the carbon-nitrogen bond. So I'm going to go ahead and do that. I'm going to erase these 2, and I'm going to put them into the bond. Nitrogen still has access to 8 electrons. Carbon now has access to 6. This is looking good, but we still don't have access to 8. So I'm going to move another 2 electrons. And it doesn't matter which 2 I move off nitrogen as long as I'm moving a pair off of a side. So I'm going to take those 2 electrons. Whoops, I just erased my nitrogen. Oop. Put him back. And put those electrons in. And now carbon has access to 8 electrons, and nitrogen has access to 8 electrons, and everybody's happy. At this point, I can redraw this, and I'm going to start to draw my Lewis dot, or draw it this way, like so. Nitrogen, boop, boop. Or I can start to draw each bond as a line. So there's a bond, and now here are 3 bonds because I have 6 electrons. There's my nitrogen, there's my electrons on the nitrogen. So, what is the Lewis dot structure of each of the following? The ammonium ion, the carbonate ion, and carbon tetrabromide. For the ammonium ion, the formula is NH4+. Now this plus is going to affect how many electrons we have to work with. Nitrogen gives me 5 electrons to work with, 5 valence electrons. And hydrogen gives me 1, but there's 4 of them, so that gives me 4. This plus means I have to take away an electron. So right now I have 9 electrons, but because of this plus, I have to subtract 1. So I only have 8 electrons to work with on this molecule. Nitrogen is written first in my formula, and hydrogen is never a central atom, so I put nitrogen in the middle. I have 8 electrons to work with. I put 2 here to make that bond, 2 to make that bond, 2 there, and at that point, I've used up all of my electrons. I can check. Does everybody have access to what they need? Each hydrogen has access to 2, and the nitrogen has access to 8, which means everybody's happy. Now, I'm not totally done with drawing my Lewis dot structure because this is a charged ion. And so when I draw a Lewis dot structure of a charged ion, I have to put brackets around it and show the charge on the outside.